Hello, ladies and gentlemen. It is 1:12 on a Thursday in May. More importantly, May the 6th. Okay. No longer May the 5th, unfortunately. No Cinco de Mayo. Nothing fancy about May the 6th. Unless it's your birthday. And if it's your birthday, happy birthday. Okay. So, in Unit 7, Day 2, what are we going to be covering today? We're going to be trying to gap the bridge between right triangle trig and the unit circle trig. Okay? So, unit circle just kind of adds a little more flavor, I guess, to the right triangle trigonometry. Okay? But before we get started, we have some definitions. Okay? And so one of the first definitions is the definition of a unit circle. So a unit circle is a circle, if I can spell it right, circle, with a radius of 1 unit. Okay? Hence the name, us mathematicians, unit circle, right? It's a circle that has, it's got a radius of 1 all the way around, right? So hopefully we remember that any circle, also this is located at the origin, okay? The unit circle is always located at the origin. And so any equation that's located at the origin of a circle, right, always starts out with this piece, and then this piece is your r here. And so in this case, our r squared, or 1 squared, is just 1. Okay? So that's the equation of a unit circle. Hopefully that seems familiar. All right? That's what we touched a little bit on that in our quadratics unit when we were writing the equations of circles. Okay? Now, given a point xy on the unit circle above, label the measures of the 3 sides of the right triangle drawn. Okay? Now, what we got to remember, all right, is when we're talking about the unit circle, we're talking about points only on this unit circle. Okay? And so, hence this point right here, which is highlighted in orange, okay, is the one we're talking about. All right? Now, what you want to do is you always want to kind of draw a nice perpendicular line to your horizontal axis. And there's only one horizontal axis, that's your x-axis. Okay? So when we're finding these points here on the unit circle, right, what we're really finding or utilizing is right triangle trig. Because as you can see, that one creates a right triangle. This one creates a right triangle. And that guy creates a right triangle. Okay? And so everything is sort of based inside this circle. More importantly, when we're finding what these points or these, what these values actually are, what these points are on our unit circle, okay, this sort of stems from the fact that we're still creating right triangles all over inside of this circle. Okay? And so when we talk about the other angles out of the first quadrant here, because really we're going to hang out in the first quadrant for a little bit, at least partially through this lesson. Okay, this is quadrant number 1. This is quadrant number 2, 3, 4. Okay. So we're going to be kind of hanging out in this area for most of the lesson. But, all right, what I'm emphasizing is this, is once you can find the values in this first section here, okay, once you're good with this first quadrant, you can find the values of any of these points along our circle. Okay, more importantly, there's specific points. Right? When you get into pre-calc and calculus, there's a certain amount of trig that you're just supposed to sort of have memorized. Right? And it starts from that first quadrant. So, given a point, x and y. Right? So here's our point, x comma y. All right? So, what we're looking at is, on the unit circle, label the measures of the 3 sides of the right triangle drawn. Okay? So remember, when we're trying to put a point on our coordinate graph, right, you always start with your x value, how far left or right you're going, right, and then your y value determines how high up or down you go on our coordinate plane. Okay, so this point x comma y is determined by this value here, and again, our radius is just 1. Okay, hopefully that's not too trivial, right? We've put points on the graph before. Okay, but so by Pythagorean's theorem, Remember Pythagorean's theorem was a squared plus b squared is equal to c squared. We sort of substitute what we have in for those values, and so now we have x squared plus y squared is equal to 1 squared, which is the equation of this unit circle. Okay, pretty cool how that sort of kind of ties back in. All right. So anyway, knowing those pieces of information, okay, we're going to find the sine of theta, which is some old hippie, the cosine of theta, which is caught another hippie, taking Opal's apples, which is the tan function. Okay, so, all right, so we go, now again, the angle we're always referencing is this angle right here. Okay, theta is always going to be that angle in that corner for the rest of this unit. Okay, it'll always be referencing that angle. Right, so your opposite is always going to be over here. Your adjacent is always going to be right there. Okay, so in this case, our opposite over hypotenuse is y over 1, which is just y. Our cosine is x over 1, or just x. And then our tangent is y over x. Okay? Okay. So, using substitution, okay, on a unit circle, the x value of the point is always the cosine of theta, and the y value of the point is always the sine of theta. Okay, and so by using substitution, we plug these in for x squared, y squared, so you get that plus sine of theta squared is equal to 1 squared. So here is our first trig identity, which you will see numerous times in the future if you decide to take pre-calc or calculus. Okay? So basically the cosine squared of theta plus the sine squared of theta is equal to 1. So what it's saying here is once we start talking about the unit circle, okay, your x and y values will be the same as comparing them to the cosine of theta and the sine of theta. So when you think cosine, you got to think x, and when you think sine, you got to think y. Now a great way to remember this is which letter comes first in the alphabet, C or S. So clearly, hopefully the answer would be C there, and so cosine will always go first. Okay. So note in a circle, an angle is always drawn to the nearest horizontal axes. Okay, so you got to figure this is 0 degrees. Okay, and so as we go around this unit circle, okay, we're going to have different measures based on how far we travel around here. Okay? And again, these triangles we create always stem from your origin, and then you draw a straight line down from that point to your horizontal axes. Okay? So for example, if we had a point here, okay, so then what we would be talking about is the angle would be this guy right here. Okay. And this would be the cosine of theta, or whatever that point would be the cosine of theta, and this would be the sine of theta. Okay? Now if that wasn't here, right, if we were talking about this angle right here, this orange one, okay, again, we're still starting at 0, going this way. Okay, so our whole angle would be, well, that whole piece right there. All right, and we'll dive further into that. But remember, this is always our starting point, and we're always going counterclockwise. Not always, but at least in these few lessons to get you guys comfortable, we're going counterclockwise in order to determine the angle measure. Okay? Now, there's other times we go counterclockwise, but for now, we're going to stick with one direction. Okay? So, So in a circle, an angle is always drawn to the nearest horizontal axis, okay? So there's special angles, okay, the ones that cannot make a triangle, right? So if we got this point right here, okay, we go from our origin, boom, there's our right triangle, and we can solve here, all right? But the problem is when you have points like these, okay, there's no way that we can draw a horizontal line to create a triangle, right? We draw a horizontal line to our, we draw a vertical, or I'm sorry, we draw a vertical line or a perpendicular line to our first horizontal, right, from our origin. Well, that's not a triangle. It looks pretty much like a straight line, okay? So these particular points on our unit circle, okay, are called quadrantal angles, okay, since they fall on the axes and separate the quadrants, okay? Now, you got to think, all right, this falls on our origin. This point is 0, 0, okay? So that means because it is 1 unit, right, it's 1 unit all the way around, right, our radius is 1, that means this point right here is 1, 0. Right? Now if we keep going up, okay, this becomes 90 degrees, right, when we start at 0 and we go up to this point up here, which I'll highlight in red, and this point is 0, 1. Right? Then we head over to, when we keep going, okay, so now we've traveled 180 degrees around the circle, and this point is -1, 0. And we keep going. Now we've traveled 270 degrees, and this point right here is 0, -1. And now we've traveled back to 360 degrees, and again, back to 1, 0. Okay? And so remember, when we're thinking about these points, okay, we got to start thinking cosine of theta, sine of theta. All right? And again, you want to think cosine as your x value and your sine as your y value. So in this case, we take a look at the cosine of all of these points, which I will highlight in orange. Okay? So the cosine of 0 degrees is 1. The cosine of 90 degrees is 0. Cosine of 180 degrees is -1. And cosine of 270 is 0 degrees. And I'll highlight the other one in blue here. And so our sine, this one's going to be 1. This one will be 0. This will be -1. And this will be 0. Okay? All right, so that's where we're getting those values from. And they call those quadrantal angles because you cannot create a triangle with those guys. Okay? All right. We're going to head right here. Okay? So, we can fill in part of this. This is the unit circle. Okay, so this is 0 degrees. This is 360. This is 90 degrees. This is 180 degrees. This is 270. Okay, so this point is 1, 0. This point is 0, 1. -1, 0. And 0, -1. All right, so far so good. Now, the other day, I had you guys do these ones. All right, and I said, hey, remember these values. You're going to see them again. Here they are. Okay, and so what we're saying is this point right here, okay, its x value is square root 3 over 2, and its y value is 1/2. This guy is square root 2 over 2, square root 2 over 2. That one's kind of nice. And this one's 1/2 square root 3 over 2. Okay? So, where we're getting those values from is, again, your cosine of theta is your x value, and your sine of theta is your y value. So here's our triangle. All right, so here's our theta. Right, and so the ratio created by this, well, opposite over hypotenuse, okay, is 1/2. And then the cosine, the adjacent over hypotenuse, is 1/2. Okay? Or square root 3 over 2, sorry. Right, the sine was 1/2, the cosine was square root 3 over 2. Okay? All right, let's move down to these ones down here. And so, now, the point of it is this, is once you figure out what these angles are here, okay, once you can figure out this first quadrant, okay, you can fill out the rest of all of these, okay? So what's kind of cool about trig is that once you know the pieces in the first quadrant, you can fill out the rest. Okay, so we will use what we call reference angles to find the angles in the rest of the quadrants. Okay, so the reference angle is in the standard position. The reference angle is the smallest angle between the terminal side, the end of the angle, and the x-axis. The values of the trig functions of the angle theta are the same as the trig functions of the reference angle. Okay, and so let's sketch this guy right here. So it says sketch 120 degrees. Okay, so we're starting at 0. I'm going to start here. And we're going to go to 120 degrees. Okay? So it says make a right triangle with the terminal side and the x-axis. Okay? So we're talking about this side over here. This is our terminal side. Okay? And there's our right triangle. Okay? So you got to figure this, right? This is 90. Okay? How far over did we go past 90? Well, this is 30 degrees here. Okay? Which means this angle is actually 60 degrees. Okay? Because 30 plus 60 will give us a whole 90. All right? And so our reference angle for 120 degrees is 60 degrees. Okay? And so it says, let's finish filling out the rest of these coordinates. Okay? I'm not going to do this for the video here because it'll be too lengthy, but you can look for this to be filled in on the answer key. Okay? But I'd like to get down to the rest of the part here. Okay? So it says find the reference angle. Okay? And so in order to find that, okay, now we're going to name the quadrants. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. Okay, and a way to sort of remember, okay, which x and y value needs to be negated, you can use this guy right here. So it says all students talk constantly, which states this. All is all positive. Okay. The S stands for the sign is negative. The talks, okay, stands for the tan is negative. And the C stands for when the cosine is negative. Okay? All right. Hold on just a second. All right. So to figure out the rest of these, okay, here's how you want to think about this, okay? You want to utilize your closest horizontal axes, okay? So when we're 140 degrees, you got to remember this is 0, 90, 180, 270, okay? And then back to 360, okay? So in order to find what reference angle we're talking about, you want to utilize, okay, which quadrant are we in, right, depending on how far degree you're over, and then you utilize your closest horizontal axes, which is either 180 or 360. Okay, so 140, I'm going to go 180 minus 140. And so my reference angle for 140 is 40 degrees. Okay, 200, the closest one to that one is 180. So 200 minus 180, reference angle is 20. About 260. Okay, not quite over the 270 mark, so the closest one is 180 still. Oops, I'm going to do that the other way around. Okay, and so that's going to be 80 degrees. And then 280 is past 270, so now we're over in quadrant 3. Okay, also this is, let's see, quadrant 2, right? No, 2 is, that's quadrant 3. This is quadrant 3. This one's quadrant 4. So 360 minus 280. And that's going to be 80 degrees, but that's going to be in quadrant 4. 360 minus 320. It's 40 degrees, quadrant 4. And 25, quadrant 1. And the reference angle is just 25 degrees. Okay? So, I didn't mean to rush through that. Okay? Hopefully this makes a little more sense. I'll have this thing filled in for you guys, and I will do this in class and kind of run through it. And so be looking for that on the answer key filled in. I just didn't want to do that in the video and take up that time here. Okay? So I'll demonstrate that in class, and so hopefully this makes a little more sense.